Hey, here's another video from weldingtipsandtricks.com. We are still working on the short production run of sewer crawler remote tractors, and we're still using the BuildPro table from StrongHand, the precision welding table. But I'm going to throw you a little bonus here because I know you're getting tired of hearing about the welding table. So I'm going to show you some good arc shots here that I'm getting with my new camera. I am working on some training videos, and I'm getting there. With some pretty decent arc shots. I hadn't quite got it where I want it yet, but this is pretty useful and instructive watching this. Step and pause. Moving about 1/8 of an inch, roughly. Add rod. Move ahead, add rod. Move ahead, add rod while you keep the arc length and the torch angle the same. Alright, let's get on with the build. Okay, we're welding stainless steel axles. 304 stainless to AISI 1010 carbon steel. And we're going to use a 312 stainless steel rod, and we're going to TIG weld them in. So first thing we got to do is we got to get them straight. Alright, you know, we welded all that bar stock on there, it got line bored, but now we got to fit them in. Now in the past, this was the operation of getting them straight. Stick a little square up there, kind of a little precision square, stick it on one side, tap it, stick it on the other side, tap it back till I got them even on both sides. Not a big deal. This is something we do all the time, but kind of time consuming sometimes when they just go back and forth. So with the tooling, that's the package that's available with the StrongHand BuildPro table, piece of cake. I was able to make a setup, just looked around for about 5 seconds, say, okay, I can use this, I can clamp that to that, I can use this for a stop, I can put me a straight edge, and once I get it set up off the first one, I went ahead and fit the axle in there right, and then I made the setup, set it up there just so a stop touched it, and then from there on out all I'll have to do is tap it in until it touches the stop and tack it and done. So that's nice. I mean, it's just nice to have the right stuff to work with, isn't it? It just makes the job go so much better. So once that stop is in there right, all I've got to do is just tap the axle up there to where it touches, and I'm ready to tack. So you know, that's just easy. That's just really easy, and the stuff is just so easy to put together because it's got these little spring-loaded type, or I don't know, spring-loaded, but anyway, little balls that stick out, and you push them out by screwing in the set screw. So they pop in each hole instead of having to use a threaded bolt, which you can use if you want. They have features that have a bolt threaded attachment that turns every hole into a threaded hole. But just using those little things, you can put things together in nothing flat. So double check here real quick, and you know, here's how I got the straight edge. All right, the tooling package comes with straight bars, stop bars. I don't know exactly what they're called like this, but they're perfectly straight. And since the holes are all perfectly straight in a line and CNC drilled, you know that if you line up two straight edges along one line of holes, you got a straight edge. It's straight. It has to be straight. So there's no questioning. There's no wondering if it's straight or not. So I put my straight edge up there, and then I put my stop up here to you know, for a stop for the axle to indicate once I got one right, to know that it was going to be right every time, and double checked it. And then from there on out, I you know, since I'm doing 17 of these, I don't want to tap back and forth each time. So I just one time do like this, tap it up to the stop, put the torch up there, hit the foot pedal. You remember I told you about popping it real hard one time for tacking, how that's handy? Well, so that's tack. Now, if I want to hold it down while I'm messing with it, I've got some one-handed operation type hold-down clamps here that just slip in each hole. You don't have to screw them in. You don't have to hook them in the slots. They just slip in, and you can hold it with one hand. I am holding a camera with one hand, using that clamp with the other. So you know, if I can do that it's easy to use. So if I want to hold it down, I clamp it down, and there's my setup for tacking those in. Another thing that I really found that I wasn't really prepared for, I didn't really anticipate, was how handy the holes around the table came in, because you got like 50 torch holders now. Anywhere you are around the table, you got a place to hold your torch. Alright, so let's weld these axles in now. Now I could walk the cup on this thing, but they're kind of slick and kind of small, so it takes a lot longer to walk the cup, and the cup's liable to slip. So I don't want to do that. I'm going to prop up against, I'm going to freehand, and when I say freehand, I don't mean prop out in the open. I mean prop up against something with my finger. Now what I'm doing here is I'm using a TIG finger heat shield to prop up right next to the hot metal, and I'm leaving the wire in the puddle. Sometimes you dip in and out, sometimes you leave the wire in the puddle. There's really no point here in dipping in and out, because it just flows in there nice like this. It's called a lay wire technique, and just using a little weave, I'm just keeping the wire in the puddle to kind of satisfy the puddle so it doesn't draw metal from the sharp edge that I want to keep there. So using the TIG finger, I'm able to prop up right next to right where it's going to get really hot. My glove would just be on fire right there if I didn't have that thing on. Now obviously there are ways you could do this without the TIG finger. People have been welding without one for a long time, but I just think it's pretty handy to just gives you more options on places to prop. You can prop right on hot stuff. So that's what I did here. I took a dry run or two and then welded it up, and that's what I like to do. I like to take a dry run and see how it's going to feel before I actually light up. Here's another angle. One of these axles being welded in sideways instead of straight up and down, just to give you a little different camera angle on it. Now I'm going to show you how to do something wrong here. I didn't really intend to, but you know, when you're welding with your arms wrapped around a tripod, squatting down looking through the tripod, and you know, it's not always ideal. I got a bad torch angle here, and you can see the undercut at the bottom toe of the weld right here. See that undercut? That wouldn't happen if my torch angle was right. So I need to have it pointed more down instead of straight into that top member, and I wouldn't get that. So torch angle is important. A little bit of undercut, it's not the end of the world. You got to keep it to a minimum. You can hardly see it from this angle, so it can't be too bad, right? So next we're going to weld these carbon steel bosses in, but to do that we're going to do a little evaluation of the combo unit, the BuildPro 256 from Everlast TIG stick plasma. We're going to see if it's any good, and I'm going to give you some good arc shots on welding those carbon steel bosses in, as well as some other stuff, and then we're going to run it through its paces for plasma cutting with some 3/4 inch stainless. So stay tuned for that in another series. Thanks for watching. WeldingTipsandTricks.com.